welcome to the RPS project. Now I've been looking at building a little Fume fan thing for when I'm soldering. You know, you get those little fan things, they've got a filter behind them, so when you're soldering all the smoke gets whipped away. Well, some of them are quite expensive. I thought, well, it's got to be cheaper to try and make your own, isn't it? So yeah, why not? The main problem I've got is how to control the fans. Well, I found it's a TC647 fan controller, and I've got the data sheet for it. It's quite thick. I haven't printed all the pages off. I could have done it on the computer and shown you, but screen capture and whatnot, but I thought I'd just print it off because it's easier to get through. What is the PWM fan controller with fan sense trademark technology? Actually got that on there. Say trademark, so I presume that must be a trademark description by Microchip. So there you go. If you happen to see or hear the word or hear me say fan sense, it is a trademark word. There you go. People like to trademark stuff. Anyway, general description, it's an 8-pin dip package. That's the one I've got. You can get it in SOIC, as you say, MSOP, different packages. The dip package is just the easiest one to get hold of and use. Well, I found it was anyway. The TC647 is a switch mode fan speed controller for use with brushless DC fans. Temperature proportional speed control is accomplished using pulse width modulation. There you go, marvellous. All you need is something like a thermistor as your input, and you just set up your other variables that it requires. I sort of will refer to this to some extent as I have a look at this little beast, and we'll see. Now, you can get other types of fan controllers, but they come in SMD packages. I found one that I quite like, but being in an SMD package, I'm going to need other things to set that up, like a magnifying glass for when I drop it on the carpet. As I'm sure to do, which, you know, hunting around for them things. Anyway, let's move on. So let's have a look at it. I'll start with the whiteboard, quick overview of the circuit, and I'll quickly go through some parts of the data sheet, and then we'll have a look at it in the flesh, as it were. So I've got this on the whiteboard now, the circuit drawn out. Hopefully everybody can see this. It's a little bit small because I've got to get quite a bit on there. It is shown in the data sheet. It's the same circuit taken from the data sheet, so that's what they suggest how you set it up. So that's what I've done. It's on page, let's have a look, page 6. So have a look at the data sheet. It is there. Quickly do this overview. So I've got pin 7 is my output. It's output in a PWM. Now, the frequency of that PWM is set up here with this capacitor here. It says use a 1 microfarad, so that's what I've done. Supposedly gives me 30 Hertz. And then that outputs to a transistor, which obviously turns on and off quickly, which allows you to run this fan. This obviously got a resistor here and this capacitor. Now, I'll go over this in just a minute. This is something else to do with their fan sense, as I've already mentioned. That's a sense pin, but over here we have two elements. Pin 3, which is the V-in. Now, normally you'd have something like a thermistor or something, some temperature sensing device. Over here, I'm not using it that way, so I've just used the resistor divider. I had a 10k pot, and then I've just set up the other resistors to give me the variation of voltage that I want on pin 1. Now, it actually states that the input should be between 1.25 and 2.65 volts to give you your 0 to 100% PWM adjustment. And I've actually got somewhere in the region of about 1.4 to 2.7, so maybe a little bit of adjustment on those resistors, but it does seem to be about right. Now, pin 3 Pin 3 is the minimum fan speed, so you can set a minimum speed of which the fan will turn so that it'll always be turning, especially when it first starts. It'll come on. It's not going to just sit there and stutter like some can. You see them sort of twitching, trying to turn, but they're not. They're just not doing anything. So this guarantees a minimum speed. Again, it's just a resistor divider set there, and it suggests in the datasheet that the minimum voltage should be about 1.8 volts on pin 3, and you don't need much current neither, so it's suggested 100 microamps through the divider. So that's what I've done, set that up that way. So quick calculation tells you what you want to do in the way of resistors to put on there, and that will guarantee minimum fan speed, and then it's adjusted here with the input onto pin 1. Now, as I was going to say about this pin 5, the fan sense, and this pin 6 here, which is actually a fault pin, gives out a fault logic, I suppose. This is designed that pin 5 will be receiving a pulse, because as this switches on and off, you're getting like a spike from this part of the circuit. Now there is an equation in the datasheet that tells you how to set this side up, so it's very helpful. So it gives you all the details you really need to do that. And what it does is, as it receives a spike, it's saying, okay, the fan's turning, that's going round and round, so there's no problem. But if the fan was to stop turning, then you would stop getting the input pulses on pin 5. And then what it would do after a certain set of whatever circumstances internally, it would then take this pin 6, which is normally high, and it would force it low, and that'd say there's a fault there, and you could have additional circuitry that would see that and go, there's a fault, the fan stopped. What I'll do is I will shut down the system and go into a reset mode. Now this does have a reset mode internally. This is why I put this capacitor here, and the circuit suggests it this way, so it attempts to reset itself if it detects that the fan has, for whatever reason, stopped turning or become very slow, and it will try to reset. Or, as I say, you can set up circuitry additional to this to have additional shutdown control, so it will shut the circuit down, protect, because like if you have this in a computer, you don't want it to burn up something on your computer, do you? So it'll control that. But I've just done it this way just because I want it to give me basic control. So that is the circuit. So let's set this up and have a look to see if it's actually going to work. So here we have the circuit set up on the breadboard. It's a bit hard to show this. Over this side I've got my transistor, resistor circuit, my input side, control, just basically all the devices, all the capacitors that I need to make this whole thing work. I've set up on here, trying to be as neat as I can, but yeah, basically I think that's just what we've got. I've got a 2-pin fan, because really that's what this circuit looks like it's designed for, a 2-pin fan. So basically it just has a voltage. So if you don't have any other control mechanism like you get with the 4-pin fans, where you put in a PWM directly into the fan, it controls itself from how you control that PWM. It has a tacho coming out. I suppose a bit more complicated to try and get in control, but this one is just 2 pins. I've got an op amp over here, but yeah, I'll go over that in a bit. It's not part of this circuit yet. Anyway, the fan, if I can get this turned on. Yeah, my power supply is noisy. It's going to be powered from 5 volts, and that's the other thing. We've got 5 volts for the main circuit, but you need 12 volts for the fan. So the fan's going to be, I suppose if I was to set this up properly, I'd have 12 volts coming in, then I'd have a 5 volt regulator to give me the 5 volts for the rest of the circuit and just take the 12 volts straight off for the fan. Now I've added a diode here across the fan because, you know, it's a fan, back EMF, we don't want to destroy anything, do we? So yeah, let's turn this on and see that it works. And hopefully you can see that that fan is turning, and it is. And as you can see, it seems to be turning quite slowly. You know, you can having this grid on the front here is quite helpful because it almost allows you to see that flicker you can get from the fan when they turn slowly. Hopefully the camera is picking that up. Now I'm going to adjust the pot, and it's about halfway, and that has actually speeded up. Now this fan's not got a lot of blow to it, but it does seem to be working. Turn it all the way up. I don't know if that sound is audible on the camera. It's picking this sound up, but I can hear that that's running much faster. There's a lot more air that's coming out of it. But of course you can't really see what's actually going on there, can you? You're just seeing this, that I've got this fan, and hopefully there's a change as I turn that speed back down to low. But you did notice that it is on. It came on straight away. It wasn't that it didn't come on. So the minimum fan speed is working just fine. It's controlling that, and we can turn up the speed as we go along. So what I'm going to do is I'm going to get the scope out, and we'll be able to hopefully see what's happening with that sense pin to show that it's giving out or receiving a signal. A bit more visual. So now I've got my scope turned on. I'm going to turn on this this unit and see what it's going to give me. So let's turn it on. Oh, need to put the power onto it. I always do that. Turn the power off and then forget to put it back on. Common. Oh dear. Now we've got something. There you go. Now, as you can see, we've got an output on that sense pin, and because this PWM cycle is turned right down, you can see there's an off point, and obviously because of the capacitor before it goes in there, you've got this what looks like this charge point, and then they've got the spike as it goes up. I presume the capacitor is discharging to some extent into that pin, but you can see these little spikes as well. So I would take it that the sense pin is seeing this spike here, these spikes across the point where it's actually got a positive input. So if I turn this fan speed up, we should get an increase in that. Yeah, and actually as it's a bit twitchy, as you can see the off period is getting smaller. It's twitching it, and you're getting more, if it'll settle, more of these spikes. I'm trying to get this to sit. It doesn't like it, does it? Just, yeah. But never mind. Let's just turn this all the way up and see what we get. And as you turn it up, you get more and more spikes. That low trough disappears until at full speed we're getting just spikes. As you can see, we're just getting the spikes. So it's seeing that spike all the way along, but without the trough, because the PWM is such a high frequency now, it's all but on all the time. So the spikes are very regular without any troughs anymore, because there's no real off point, because the fan's on at 100% speed. So yeah, that's a good demonstration that that sense pin is seeing an input and it uses that input to determine that the fan is working and that the whole system has an input and will continue to give an output without having the fault pin go low. Brilliant. I love this little circuit. This little IC is really quite nice. I love that. Now this is just a 2-pin fan, and I'm wondering if I can make a 3-pin fan, one that has a tacho on it, such as this thing from a Casa. Will this work on this circuit? I suppose I better get and have a look. So now I've got this other fan set up on here, this nice little Casa, and I'm going to turn it on and hopefully it should work just as well. This is where, before I said I've got an op amp on here. Now with this circuit, it's really designed for a 2-pin fan, but this is a 3-pin, so this yellow lead is a tacho output. Now I didn't want to leave it floating because I know that sometimes that can cause a problem with these fans. Sometimes it doesn't, sometimes it's okay, but so what I've done is I've just taken it out to this op amp and just used the op amp as a buffer. Just a basic buffer with a capacitor and resistor on the output of it, just so it's got something to give it a connection to ground, but also give the tacho something to be an input into, and the op amp seemed to be the sensible thing to use. So yeah, so there's no, I don't have a floating output from the tacho, just to try and keep it more stable so it'll work properly. So let's turn it on and watch it go. Yeah, and this one has got little LEDs on it, very nice. And I can see, even though the camera's not angled at it, I can see that the scope has got a good output from this one. That's a nice output. So let's turn the speed up on this and see what we get. And it is speeding up. Oh yeah. Wow, that's really ramped up. Yeah, there's a lot more. This is a lot faster. This fan, I can feel that. A lot more airflow on there. Yeah, and that's not giving me any trouble at all. I've got full control over this fan. So I turn it down. Don't know if you can see that change, that centre bit. You can see on the centre of the fan, and also those LEDs help show the flicker, doesn't it? So you can see that fan rotation. Hopefully, I hope it's coming out on the screen, on the camera. But yeah, that's working quite nicely. I like that. There's something else that I actually want to show you as well. Now this is stated on, let's get my data sheet, on page 7. Let's grab hold of that. And it says here on power up that V out, that's the output, is on for 32 cycles. So your PWM that comes out is actually on fully. There's a full on period where it's not PWM, it's just on for 32 cycles of the PWM clock. This ensures that the fan will start from a dead stop, and I can show it on here because we've got the LEDs. And what should happen is, for about a second, these LEDs will be on slightly brighter. Let me just turn this off, let it stop, and then when I turn it on, these LEDs will be on slightly brighter than when it sets into its PWM cycle, because for those 32 cycles it's fully powered on, just to make sure it gets going. So are you ready? 1, 2, 3. See that? See the light change there? Those LEDs were bright and then they went dull because the system was giving it a really good kickstart, saying, yeah, we're going to make sure that you start. And up it goes in speed. Wow, that's quite a hefty fan. That's blowing quite a lot. I like that. And then back down on the speed. Yeah, that fan controller works really well. I like that. That TC647. Once you read the data sheet, it gives you all the information you really need on the data sheet, because it's very helpful. Some data sheets aren't, but this one is. Got this working really nicely. So there you have it. PWM control of a 2-pin and a 3-pin fan using the TC647 from Microchip. Nice and simple. It's a great little IC. The data sheet, I have to say this again, the data sheet is very, very helpful. Some data sheets aren't very good. They give you a few bits of information. You're not quite sure how to set it up, and you have to sort of work it out on your own. This one gives you all the steps to be able to set it up properly. So yeah, all you need is sort of like half an hour read, and you're on your way. You'll be able to get this thing going. I like it. It's you know, great because you don't need any other devices. You don't need your Arduino or whatever else, you know, that your mates are having a go with, you know, to make this thing work. You just need, if you want, a thermistor, temperature sensing device, or as I've used, just a voltage divider, and you can get this thing going, and really quite reasonably, with quite a lot of fan speed coming out of it, blowing a lot of air depending on which fan you've got, which is another thing. Obviously, if you know what your fan is and what the specs are of it, you can set this up even better. I don't know what these two fans specs are because they're just two old fans that I've had hanging around. I think one is out of a power supply. This one here is actually probably off a power supply, you know, the big one that sits in the top, bottom, whichever way you look at it. Yeah, and the other one is a case fan. So there you go. It works. It's nice. It's a great little device. Give it a go. Anyway, if you like this video, give me a thumbs up. If you didn't, you know what to do. Subscribe, and all comments are welcome. See you next time.